right, hi everyone. Today I'm going to be talking about two different things, two plugins that my company has developed, a plugin for Gaia and a plugin for Perforce. Now, first a little bit about myself. My name is Ambrosiussen, like Chris said. I'm a technical artist. I used to work at SideFX, where I started on the game development toolset, which then turned into SideFX Labs, for which I was the lead for a couple of years. Worked on many different projects with customers to really understand what is it that games customers do, what is it they actually need, and develop tools specifically for that through SideFX Labs as a way to release that. After that, I started my own company in the Netherlands called Bismuth Consultancy. We're a company that connects freelancers with companies that are looking for creatives that help them do various things. Most of them focused on game development and just real time. So not necessarily just games, but also any tech companies that use, for example, real-time engines such as Unreal or Unity or other means to do projects using Houdini in the loop, so to speak. So yeah, like I said, my company also does custom development for companies. So two of these are what I'm presenting today. The Gaia integration for Gaia 2 and the Perforce plugin. So to begin with, for those that don't know Gaia, what is Gaia? Gaia is a procedural terrain design software that enables artists to create highly detailed and realistic landscapes through a node-based workflow similar to Houdini. It's also procedural. It's used for pretty much anything, games, films, VFX, whatever it is, you name it, you need terrains. A lot of people use this. So what does Gaia look like? It looks like this. This is Gaia 2.0. It released about a month ago, I'd say, from now. You can see it has a viewport, 3D and 2D, to view terrains that you're working with. It has a node editor similar to Houdini. You see it there at the bottom, where once again you have inputs, outputs. You wire them together to define what it is that you want to do to create your terrain. You can also see that it has parameters, which you can see there to the right, top right. So as you can see, there's quite a lot of similarities between Gaia and Houdini, which is why Quad Spinner, who's a developer of Gaia, thought it was a really great idea to bring some of this technology for a really great look dev of making terrains look really good into Houdini to sort of add an extra set of tools that you can give Houdini users. So here are a couple of examples of terrains that you can create with Gaia. I did not create these. I can't make beautiful terrains, but they sent this to me as a few samples to show. So here you have a really nice looking terrain with different types of rocks and grounds to combine together, some coloring there. Same for this one. As you can see, some varying rock types and erosion being applied here, also with some really great colors. And then here is a picture I really liked. This is not a 3D terrain. This is just the color map that got generated using Gaia. Yeah, I think it's something that's fairly straightforward to do in Gaia, but in Houdini this takes quite a bit of time to basically create something like this, which is why I think this toolset is a really nice addition to what Houdini already has to offer in terms of terrain software. So you might be wondering, why is there a new Gaia integration for Houdini? We already had a Gaia plugin before. It was called the Gaia Tor processor, shipped in SideFX Labs. That's true. But it's a little bit different from what the new plugin does. So in the past, for Gaia 1, you used to open up Gaia, you would define your network, just like you would in Houdini. You create your little graph describing what it is you want. You mark what your inputs and outputs are that you'd like to expose in Houdini. You wire nodes together that you want to do your operation with, and then you also mark the outputs that you want to bring back into Houdini. So the different layers that you'd like to expose back into Houdini, for example, flow, wear, deposit, height, in this case for an erosion node. And then you'd save that up into something called a Tor file, and you would then be able to evaluate that Tor file inside of Houdini using the Gaia Tor processor. And so as you can see, this is sort of similar to the workflow of HDAs in Houdini, right? You make a little network, you promote parameters, you promote inputs and outputs, and then you just evaluate that, and you use that over and over on different types of terrains. Now, this is great if you want to run similar operations on multiple terrains that all have similar outcomes that you'd like to achieve, but it's not that great for artists that are sort of experimenting and creating landscapes using different nodes and mix and matching them sort of to experiment. So that's what we wanted to do with Gaia 2.0. The goal was essentially to make it so that artists could just work in Houdini the way they do normally, right? Just drop down any node you want, change the parameters, and do what you want to do. Now, technically, you could do this with the Gaia Tor processor. You could just wrap up every single node in Gaia as a Tor file and just use it like that. But that's quite a lot of work you have to make artists do, which is, of course, not what they want to do. So we wanted to bring every single node that exists in Gaia over into Houdini as a native node that you can just use to modify your terrain with. And that's what Gaia does with the 2.0 plugin called Gaia to Houdini. So the other thing that we wanted to do is make the plugin extremely fast. We wanted to not feel like a plugin. We wanted it to feel like a native integration into Houdini. And we were experimenting to try a bit of how fast can we move data from Houdini to Gaia and back to Houdini. And that's when we stumbled upon using shared memory for that. And after some experimenting, we managed to do an 8K terrain, bringing that to Gaia, doing some processing on it, and bringing it back in 1.2 seconds, which is very fast, right, compared to the old plugin, because what that was doing is it was saving all the layers that your terrain has, the volumes, as images on disk. Then Gaia would load up those images, reassemble its terrain, do the processing, and then save images back to disk, and then Houdini would load those images back up, which is a lot of file I/O. And if you have a hard disk instead of an SSD, it will probably die after a while because you're writing so much data to disk and reading it back. So those are sort of the two core principles that we wanted to achieve with the plugin, which was making it super easy to use, just make it feel like a native integration, and make it extremely fast. Now, and here's a video that shows you what such a workflow looks like using the Gaia 2.0 plugin. So as you can see, we just have a normal network. We start with a height field. We use a slump node to just make the height field look great right out of the box. It's a generator. We then use a draw curve node because I'm going to sort of create a Grand Canyon-like terrain. I want to use this curve to describe where the actual canyon is on the terrain so that I can just do this procedurally. So just draw it in this case, but you can use whatever method you want for a drawing curve. Then I'm just simply resampling that to make it a bit less noisy. I array that back onto the original terrain because I wanted to carve out of that terrain. I remove the extents. I create a little curve that I want to sweep across the backbone. And then I just project that onto my height field using the normal native height field nodes in Houdini. Then I use the Gaia fractal terraces node to just create some terracing in the area that I just projected. Play around with the parameters, and as you can see, it's super fast in just modifying those. I then do some erosion that Gaia has, play around with the parameters there. Once again, as you can see, change the seed. I get immediate feedback in terms of what it does. And the results that the Gaia erosion offers are just, they're amazing right out of the box, even for someone that doesn't know how to do art. Then some more terracing to sort of take that erosion and make it look more terraced again. Apply a sandstone, and then afterwards I am going to extract the flow map from that, which then later on I could potentially use for texturing. And there you go. This took me maybe 10 minutes to make. As a non-artist, I was able to create something looking okay, I guess, in my opinion. If you give this to an actual artist, they can probably make something way better. So what does the plugin do as well? It also brings in a bunch of generators, is what Gaia calls it. Generators basically are just pre-made little terrains that you can use as a starting point to do things with. So you can see that you can create canyons, you can create crater fields, plates, ridges, rugged terrain, and slump. And I find these extremely useful because you can just use this as a starting point instead of just using noises to create some basic shapes. Instead, you just cram together some of these presets or these generators and use that as a starting point, because then you already have something that looks pretty great out of the box without doing anything. The plugin also has a bunch of texturing nodes that Gaia offers. These are all exposed as different masks and layers, which you can then use in Copernicus, for example, in this case, by importing those layers. And then you can layer those together or do some blending or drive some material properties in, for example, Unreal or in Redshift or whatever it is you're using for rendering. And once again, as you can see, super fast to tweak with. You get immediate responses on how something looks, which is great for look development because you can focus more on making artistic decisions rather than waiting for something to cook or to process before you can continue. Now, another image of a node called outcrops. The reason I wanted to show this is not because it's a really special node or it does something unique or different from anything else, but just this single node converts something like a basic noise on a height field to something that already looks believable. I didn't change any parameters. It just does that. And that's sort of, I think, one of the core things that Gaia offers, which is all of these are already fine-tuned for delivering highly artistic results without having to do quite a lot, while still offering you the ability to play around with parameters and modify how it looks. So let's look at something else that is also really great about Gaia in Houdini in this case, is that the erosion is resolution independent. And so what that means is, in this case, I'm doing this erosion on a height field that I believe is a resolution of 1K. And you can see I get certain cuts being made in the terrain, like these flow lines or parts being cut out of the terrain. And then once I'm happy with that, I can go back to my original height field, and I can just change it to be a different resolution. In this case, I'm going to use, I think, 4K or 8K, and then it just redoes the erosion, but you get the exact same look, but just with more detail. So there you go. You can see I changed it to 4K. We wait a little bit for it to process, and there you go. Now it is a 4K terrain. You can see it has a lot more fine detail, but the overall shape of the terrain remains the same, which is super important when working on something. Because you can just make something look great and work fast with a lower resolution, and then just know that it's going to look similar or almost identical when you use a higher resolution. Now, how does the plugin actually work? I also wanted to show a bit of the inner workings, because the plugin at some point will be open source, and just exposing all of the internals. Currently, it's black boxed, not because we don't want you to know how it works, but we probably expect some changes in how it works internally, and it will probably break your setups if you intend on modifying any of it in the meantime. Now, the plugin works as follows. We have Houdini, and then we have a local service running called Gaia Server, which communicates with both Houdini and Gaia core using TCP communication. And what we do in that TCP communication is Houdini tells Gaia what is the resolution of the terrain that we're using, what are the parameter values that the user is doing, what are the images that it expects to receive and modify, and then it tells it, hey, just go and do this, while both knowing what the same shared memory is that we want to use. Now, to pass volumes really fast from Houdini to something else, you can use this method called allVoxels as string, which just immediately grabs all of the voxels as a float array in Python that you can then use for whatever purpose you want to do. So in the past, I used to just loop over all the individual voxels and grab the float value of a specific volume. But if you do that for an 8K volume, that's going to be extremely slow. This just reads all of it at an instant almost. Now, once we've gotten all of those values, the Gaia plugin, like I said before, uses a shared memory map with Houdini and Gaia. And with the TCP communication, both Houdini and Gaia know what is the named memory address for the data that both Gaia is reading to and Houdini is reading to, and both are writing to. And so the way we do that is using the shared memory from the multiprocessing module in Python, where we just write all of the individual image planes. So for example, flow map, height, mask, whatever it is, we just write those raw float arrays into that shared memory address, and then Gaia reads from that, and then it reads back to that once it's done with it, and then Houdini reads from that and parses it back into a volume. So this is why it's extremely fast in passing data from applications from and to each other. Now, the cooking logic, like I said, the plugin at the moment is black boxed. We generate a Houdini node, a unique Houdini node, from every single definition inside of Gaia. And I wanted to be efficient in how those are generated and how I would be able to do bug fixes in any of the code. And the way I've done that is by creating a node called Gaia Core, which contains all of the code that the node is running in the Python node called Cook Engine. And all that Gaia Core does is it creates a string attribute as a detail attribute, and it just passes that, and the Python node reads that as the actual channel expression for the Python sub to evaluate. And so what that means is if I need to make a bug fix in the cooking logic of the Gaia plugin as a whole, I just need to update the Gaia Core node, and all the other HDAs that use that will automatically get those bug fixes. Now, of course, you could use an external module to do that, but since we want it to be black boxed, yeah, we'd have to ship compiled Python code, which is a bit difficult to do, especially if we want to use it in multiple Houdini builds. Then another thing, this is something that SideFX hopefully is going to look at. There's a lot of bug reports already made about this, but that is how to surface errors that you raise in a black box asset. If you have a Python SOP and you, for example, say raise node error, and you look at the little warning icon on a node, it's just not going to do anything because it's black boxed. And the reason for that is, if it were to show you what the error is and where it is coming from, a user would know about the internals of a black box node, which is, defeats the purpose of a black box node. What you can do instead is a little trick, which I got from Henry, previous talk here, is you just use vex and you use the error method to just pass in a string attribute, and then suddenly it is allowed to raise an error inside of a black box asset. You just have to do it using vex, which is a bit odd, but it works. Generators, how do those work? And what I mean by generator is it creates a mountain Gaia node and then attaches a height field node on top of it because it needs an input. We just do that using the node scripts that live inside of the definition. And so if you were to do this yourself, what you can do is go into the type properties of a node, go to the interactive tab, click on the actual shelf tool definition of a node, and then in there you'll find the typical code that's there depending on context, where it says import subtool utils, and then node equals subtoolutils.generic tool, which just instantiates the node and takes care of all the other node creation boilerplate code that's there. And what you can do is you can modify that and add your additional logic to that. So in this case, I just try and set the color and automatically generate a height field node that I plug into the first input of the node. And of course, I have to wrap this in a try except, because what happens if, for some reason, a user does this in a locked environment where you can't create nodes, then this process would fail, which we don't want. Here. So two videos made by Robert, who was kind enough to try out the plugin and use it. What he did in the first video with the audio was extract all the different channels from a music video, and then use Houdini's power to drive the creation of height from that. And then he used the Gaia plugin to do some additional processing on top of that to extract the masks, but also do erosion on top of it. And this second video here is also something really interesting, where he got an animated height field and also then running erosion over that temporally, which allows you to do something really cool like this in an almost interactive fashion. So instead of having to wait 30 seconds per frame, this is almost real-time erodes like this, and you can use it to do whatever it is you want to do for cool stuff. Now, if you want to start using this Gaia plugin, it already is shipped in SideFX Labs. So if you've got SideFX Labs 20.5.345 or newer, you will already find it in your tab menu. So then you can start using it. Now, you do, however, need a license for Gaia, and I just put a quick slide on here because you do need a specific license. You need at least the Gaia 2.0 professional license or the enterprise license. And these, by the way, are, I had to say from QuadSpinner, these are perpetual licenses and a one-time fee you basically pay for that. So it's pretty good for the tools that you get in Houdini to do this kind of work with. Now the second plugin I want to talk about, and that's the Perforce plugin. Now, if you're a game developer, you probably know what Perforce is, and you also know what the pains are of working with Perforce in Houdini. So for those that don't know what Perforce is a version control software. It allows you to work collaboratively in very large teams. So you may be wondering, how is that different from, for example, GitHub or something else? Perforce really is binary first. So it's really used to dealing with very large files, which is very important for game development because we often deal with mostly binary files and not so much code, which is what GitHub is great for. It's also really big in game dev. Any big game studio that you probably talk to or work with very much are likely to use Perforce or have their own custom thing, but Perforce generally is the standard to use. So what is Perforce for a user? For a user, it's pretty much just working with files on disk that get mirrored on some cloud location or on some server that you have within your studio. And the difference between something like GitHub, for example, is it tells you if other people are already working on a specific file. So that means that you won't get clashes between two people working on the same thing. It tells you what it is you're doing. It allows you to branch. It allows you to switch back between older versions, which is great for game development workflows. Now, why is Perforce annoying to use inside of Houdini if you don't have this plugin? It's because of this. And this is something that happens quite often if you use Perforce in Houdini, where you make files read-only. And that is that when you try and save your HIP file, it just says this, permission failed. And the reason for that is Perforce by default makes all the files read-only when you use it in your workspace, which means that when you try and do something like a save in Houdini, obviously the file is read-only, which means you have to first check it out in Perforce before you can actually save it. And that's quite annoying because then you have to open up Perforce, you have to find the file in the file structure, you have to then say checkout, then you can go back to Houdini, and then you can save it and do whatever it is you want to do. Now here's a little promo of the plugin and what it has to offer to you as a user using Perforce. All right, so that was a quick promo. As you can see, I didn't even have to open Perforce, which is great, which is what I want as a user. I can just deal with working on my Houdini scenes instead of having to deal with Perforce. It just does it for you. Now, what does the plugin offer you? We're just going to take a closer look at the individual features that we saw in this promo video. First of all, you get a shelf. The shelf allows you to configure how you work with Perforce. So you're able to set your workspace, which repository is it that you want to work with, what's the workspace that you want to use. You're able to enable, disable a plugin, because sometimes you don't want to use Perforce for a specific project. If you're just experimenting, for example. It has a button for checking out all dependencies. So it goes through your entire HIP file and finds nodes that are writing files to disk that may need to be checked out or added once you do something in Houdini. It can check out the open HIP file. It can revert HIP file back, edit existing change lists, and also submit existing change lists. Now, adding and checking out files, whenever you are, for example, saving a new HIP file to disk, it needs to be marked for add in Perforce, which means you are telling the server, hey, I'm creating a new file that I also want everyone else to have access to. And instead of opening up Perforce, it just automatically pops up this UI, which says, hey, you have this file added, or in this case, it's an HDA. It allows you to either create a new change list, give it a description, or use an already existing change list that you add or modify the description of, and then you just add it. And that's it. That's the only thing you have to do. Submitting change list, the same thing. You can pick whichever change list it is that you want to submit. You can exclude certain files. You can include other files. You can modify the description, and then just hit submit, and it will submit it like you would in Perforce itself. Another really great thing that I use quite a lot is the revert functionality on HDAs and HIP files. Yeah, that's already laughing, so you know what I'm talking about. When I have a version from the server of the HDA that I have locally, I make some experiments to it and I somehow screw up the node, I can just hit revert and it will bring it back to the version that exists on the server, which is great for just experimenting and not have to worry about, hey, now I've accidentally submitted a version to the repository that I don't really care about. As I've already spoken to some here, they have their own Perforce integration that they've written in the past, because everyone does custom things with an integration in Houdini. That's why the plugin also has an API that wraps around Perforce's SDK, which allows you to extend the plugin to do whatever it is you want to do, right? Because we all know everyone has their custom workflows. They want something to work in a very specific way, a little bit different from what a default Houdini solution offers. They can just do that using the Python API that the plugin offers. So the plugin itself is now free and open source. It was recently acquired by SideFX and is now shipped for free with SideFX Labs. So if you are using Perforce, you can just use this for free and do something with it. So once again, thank you to SideFX for making that happen. Now it's just available for everyone that uses Perforce. Now, a closer look at some of the things. The P4 Houdini API, there's a lot of already pre-made utility functions that you can use. You can use this, for example, to create your own shelf tools that you use in your pipeline. You can make your own pipeline tools or extend existing pipeline tools that you have. Maybe you want to use it inside of PDG. You want to add new context menu options for files, for HDAs, for HIP files, for whatever it is you want to do. You can just use either one of these that already exist. These are some of them, or add your own to the Python modules. Now, that API is also what the plugin itself uses for everything. So this is how the parameter menus that we saw earlier are also created. For example, the ability to right-click on a file parameter and just check out that file that you're either loading or saving to disk. It just imports the P4 Houdini plugin. It figures out what the path is of a file that you are either saving to disk or reading from disk, and then it just checks it out using that single line you see there, P4 Houdini.file checkout. And the same thing for file revert. As you can see, most of it is just things that have to do with Houdini and not so much with Perforce. It's just a single line that you call where you just say file revert, here's the file, and it just takes care of it for you. And this is another example of, a great example of what you could extend it to yourself. You could, for example, add an option to revert to a very specific version in the past. What about these UI pop-ups that we have? How do you automatically pop these up when you hit save on a HIP file or when you create a new HDA? How do you get this to show up in Houdini when you do a certain action? And the way you can do that is using startup scripts to register callbacks that you can run whenever something happens in Houdini. And the ones that I'm using are the Python RC node. And this script allows you to register callbacks. It gets run during the startup sequence, which, for example, allow you to do something like this, where at the bottom, you can see that I say, hey, for HDAs, I want to add an event callback when an HDA is being saved, or before it is being saved, or after it's being saved, so that I can call very specific code before an HDA is saved or after it's being saved. And the same thing goes for HIP files. As you can see there, I run the handle before save from the Perforce plugin before a HIP file is saved. For example, I need to check out the file first so that it is writable. And after it's been saved, this is useful, for example, if I have a new file that Perforce does not know about yet, so that I say, hey, Perforce, here's a new HIP file I want you to register in Perforce. So this is also how the plugin works and pops up all of that UI. It just calls these callbacks. Now, what about my own HDAs or ROPs that exist in Houdini? How do I get Perforce to automatically check out files that those are writing to disk? Now, that's where the API is really great for, because you can do two things. First of all, you can add yourself to the post-frame scripts, the plugin to automatically add or check out a file. Or you can use something else, which we'll see in the next couple of slides, to automatically detect that, hey, this is a custom ROP that I've created. I also want the Perforce plugin to be aware of this and understand that when this file cooks, it is writing a file to disk, which I also want Perforce to know about. Now, once the plugin is called, as you can see, automatically it will create a new change list in this case and just add that file to a changed list. So this is something normally you'd have to do manually in Perforce. Now, this is the second method I was talking about, which is the automatic node checkouts. There's a JSON file that lives in the plugin root called p4node checkouts.json. And what that allows you to do is it allows you to just describe node type definitions. For example, a file SOP, file cache SOP, ROP Alembic, KineFX, FBX animation output, ROP geometry, and all these other nodes. These are some of the default nodes that exist in Houdini, but I just added them to this JSON file so that the plugin knows, hey, these are nodes that are writing files to disk, so I probably want Perforce to be aware of files that this is writing. And it allows you to do something really interesting, which is describing what the file parameter is that's, describes the file that you're writing to disk, but it also allows you to make a little expression, because sometimes you don't want to specifically write the file to disk unless a certain other parameter is correct. And now, one such example is the file SOP. And the reason for that is, at the top of a file SOP, maybe you've seen it, you can either have a file SOP write files to disk, or you can have it read files from disk. Now, if you're reading files from disk and you're not modifying those files, there's no need in checking those out because you're just reading from them. Nothing is going to be written to those. So in this case, the expression states, only care about this file and the file that is saving or reading in this case, if the file mode is set to writing files. So these are some of the little things that you can do. And this is useful because oftentimes studios have their own custom wrappers around ROP geometry or around other ROP nodes that are writing things to disk. So I want to make sure that they're also able to use their own custom ROPs with this plugin. Now, how do you get this plugin and how do you start using it? Surprise, surprise, it is also shipped in SideFX Labs. It's a zip file that exists in the optional folder. To install it, it's really simple. You just extract the zip file to somewhere on disk, like you would with any other Houdini plugin. You copy the JSON file that lives in there. You drag it into the packages folder in your user preferences directory for Houdini. You change the path to be where the plugin is installed. Or if you have a larger studio and you have IT taking care of this, they can also just do it for you. But this allows you to describe where the plugin is. Once you've done that, just open up Houdini. Click on the Set Workspaces shelf tool. Allows you to specify the server, the user, and the workspace. There's some utilities that allow you to automatically configure this. Or it just automatically picks up environment variables, or it automatically picks up the p4 config file that you may have for your repository. And that's it. Then you can get started with the p4 Houdini plugin. And that's it, what I had to talk about these two plugins. Thank you. Any questions?
Let's start over here. You mentioned PDG in the ways to extend the functionalities. I was curious, are there any native PDG nodes, tops, that are shipping with the P4 Houdini?
No, they do not, because there are some top nodes for Perforce already that you could replace with this. That's probably a good idea to do that so that everything is unified. But at the moment, those are not in PDG. I mean, technically they are because you can use the automatic node checkouts that you saw, right? So if PDG is calling, for example, a ROP fetch that is writing things to disk, then yes, that will automatically be picked up. But there's no dedicated node in PDG yet because I haven't really found a use case for it yet. And studios also really haven't been asking for it at the moment.
A follow-up is, if you're creating file names in PDG, how does the auditing work, where it knows what files you're writing out, what needs to be checked out or checked in?
Yeah, so you're talking about the dependency checking in that case, or are you talking about how it adds files to Perforce?
Yeah, like if it's adding files or opening them for edit, things like that.
Yeah. So if, for example, you're doing that with the ROP fetch, right, where it's calling the ROP geometry, that is automatically going to evaluate what the file parameter is writing to when that node is actually cooking using those callbacks, so that it would know what those files are.
But if those files are being generated by attributes that maybe take a moment to cook,
yeah, that's
it's going to have to cook all of that, right?
So that's why it's doing that after the node has been, after the geometry has been written to disk for adding it. But for checking it out, it would use the pre-frame script you could use for that, which also means that that gets run just before it is writing to disk. So then those parameters would already be have been evaluated.
I'll come and get you, John, in a second.
Great talk, Paul. How do you find all the time to work on all these plugins alongside your jobs?
Time management. And I have, like you said earlier today, I have 8 arms, so that also helps.
That wasn't my real question, but cool. That was really awesome. Very excited about the Gaia plugin, obviously, and the Perforce plugin, but the Gaia plugin for me is pretty related. I was wondering to what extent future Gaia updates are going to be supported by the plugin.
Yeah, so there's a couple of more things in the works for the Gaia plugin. At the moment, it's mostly focused on height and masks, but the next thing that we want to look at are colors. So, Gaia has quite a lot of things like color erosion and those types of things. Those would be really great to have inside of Houdini using the plugin, so that's something that we're looking at next. But we're also looking at specifically feedback that users are giving us that are using the plugin or requests that they have. So we very much intend on adding those to the plugin. So it's very much a ongoing development. It's not something that, hey, here it is, have fun with it, that's it. It's an ongoing thing based on user requests and feedback.
Awesome, thanks.
Kudos, great presentation. On the point about Gaia plugin and the shared memory, which I don't have a lot of experience in, so I'm curious, the data volatility between the round tripping that you said happens via TCP versus two applications potentially hitting that same shared memory, who's responsible for reconciling any discrepancies or error checking? Is it the Gaia server or native?
That's the core application of Gaia itself. The only thing that the Gaia server process does is it handles the communication between the two, because that allows us to make very quick updates to the Gaia server without having to either make changes in both Houdini and Gaia. So that's just the way that we do it. The TCP communication only handles the updating each other about what the status is and what we expect in terms of data. The shared memory is what handles all of the data being sent from and to both applications.
So potentially, could you have an instance where two applications are reading and writing to the same data, not in sync, but?
So if you're talking about multiple sessions of Houdini, so those would have separate memory maps. So right when a new node is starting, either it is reusing a shared memory address that another node has been using, if, for example, it's the same resolution, or it has the same properties. Otherwise, it's going to just create a new one and shut it down once it knows it's done after some while, or if it knows that a new node is going to be processing a large amount of data.
Cool. Thanks.
Other questions? Yeah. For some reason, this middle section is empty with the
screens are left and right, so yeah.
Hey there, thank you for the presentation. I wanted to ask if this Gaia plugin, does this work with Unreal Engine, if you're with the Houdini engine, basically, when you import it as HDA?
Yes, yeah, I've briefly tested it. It does do that, just using Houdini engine, because at the end of the day, Houdini engine is just Houdini without an interface in rough, broad strokes. So yes, it does work like that. In addition to that, Gaia does also have a plugin for Houdini specifically, but then you don't have Houdini, of course. But if you want to use Houdini in the loop, then yeah, just use it the way that I've shown it today, and then you should be able to use it in HDAs you bring into Unreal.
Awesome, thank you.
other questions. All good. Thanks, Paul, for great presentation.
Thank you.